Hello everyone, today I'm gonna talk about our paper on improved architecture for path-based animal identification through semantic segmentation distillation. I'll start by explaining a little bit what is animal identification. We want to train a model that basically retrieves images of the same identity. Given a query that has a certain identity, we want to find images of this individual in the gallery. This is important for wildlife conservation, population dynamics analysis, and better comprehension of animal behavior. So the best methods on animal identification are part-aware identification, which basically decompose features into local paths. Those methods are different from global-aware identification because they pay more attention to fine-grained paths and they are less sensitive to shortcut or spurious features. But sometimes they rely on ground truth pose annotations, which brings us to our method, part-aware vision transformer or PAW-ViT, that is driven by three main questions. First one is, how do we design an architecture for part-aware animal RAD? We choose to use the vision transformer, but since it's part-aware, we cannot use the global token or the classification token. So we replace it by k-path tokens plus a background token, which leads us to the second question, which is, how can we guide the network to focus on discriminative body parts? Basically, we want these path tokens to focus on the different discriminative body parts. Here we're gonna define coarse or pseudo-semantic segmentation masks that we're gonna use for that. Basically what we do here is we employ an attention to mask decoder to convert the attention of the path tokens towards image tokens into masks. And we make each part specify on a different mask or on a different body part by supervising this with very classical segmentation losses like the exponential logarithmic dice loss and the exponential cross entropy. Those losses are used together because the dice loss is basically more general on the mask and the cross entropy is more on the pixels, so local. And the third question is, how can we aggregate those paths into one single descriptor while extracting the most important parts? We do that by passing the path tokens through an aggregation block that fuses the tokens into an aggregation token. Notice that here we do not use the background token. This is a way of us to suppress the influence of the background. This aggregation block is basically based on cross-attention mechanism. The path tokens are supervised by an orientation loss, which is a binary cross entropy, and the aggregation token is supervised by reidentification losses, mainly the cross entropy loss and the triple loss. This is our final architecture. Notice that everything inside the gray box is only used for training, and at inference, the aggregation token is the only token used, and down below is our final multitask loss. There are many animal re-ID datasets, but here we're gonna focus on two. The Amur tiger re-identification dataset composed of 75 tigers, and the yak re-ID composed of 103 yaks. We're gonna generate pseudo-masks by defining a number of paths k and generating those using an ensemble of pre-trained segmentation and key point estimators. For the Amur tiger, we define 5 paths: the head, the body, the hind legs, the front legs, and the tail, and for the yaks, the same, but without the tails. For the results, on the yak RAD dataset, we obtain the best results compared to the state-of-the-art on both simple testing and on hard testing. Hard testing is basically the simple testing, but with more difficult point of views. And down below here, we show a top 5 retrieval comparison showing our superior performances compared to the baseline vision transformer. On the Amur Tiger, we also show the best performances, especially on the cross-camera set, that is the most challenging one. And again, we show a top 5 example showing best performances than the baseline. As a result, we have a performant parallel method with focus on visible parts and ignoring the background, very interpretable. As you see here, the attention masks generated by all path tokens showing that we successfully focus on different paths. And for the future, we want to test our approach on other types of animals to lower the reliance to teacher-generated pseudo-masks and to better handle the multitask learning. Thank you very much for listening.